Hi and welcome back to my garage and my 1920s IXL lathe restoration project. In this fourth video I will install the motor and belt tensioning system and get the lathe running for the first time. By the end of the last video the lathe was cleaned, painted and mostly assembled. If you haven't watched the previous 3 videos, I'll leave the links in the video description. The colleague who gave me the lathe also gave me a countershaft and a small single-phase motor. The motor drives a small 3-inch pulley and spins at 1425 RPM. The countershaft is fitted with a 6-inch pulley driven via V-belt by the motor and a 3-steps step pulley that matches the lathe spindle. This combination of motor, countershaft and spindle pulleys give the lathe 3 speed options of around 1100, 700 and 420 RPM, which are a bit too fast. Ideally, the speed range should be half of this and going as low as 80 RPM. So this configuration isn't gonna be suitable in the long term, and I need to sort either a different countershaft pulley size and back gear or a 3-phase motor with a VFD. In order to get the lathe running, I knocked together a wooden frame using 2 pillow blocks, mounted the countershaft and assembled the motor. Since I didn't know the size of the belts, I ordered one of these configurable linked belts. The lathe also came with one, and I decided to reuse it to drive the countershaft. This was a stupid decision. The bang you just heard was the old belt splitting. Luckily, it stayed in place and didn't hit anything or anyone. After installing the new belt, which by the way I had from start, the system was a bit more trustworthy and I could start using the lathe. It was definitely not a good idea to use a very old belt. While assembling the lathe, I realized I would need to check the overall headstock and chuck alignment. So I ordered a precision ground 20mm silver steel bar to use as an alignment aid and also bought a 0.01mm DTI. I placed the silver steel rod in the chuck and turned the lathe on. I knew I would have some run out due to the 3-jaw chuck, but I didn't expect this much. The bar is wobbling quite a lot. So I decided to measure the run out on both ends. In the unsupported end, there is almost 2.4mm of run out. And near the chuck, we have almost 0.3mm. So to chase the source, I removed the chuck and measured the run out of the spindle mount. Luckily, only 0.02 mm. After that, I reinstalled the chuck's back plate and cleaned it with a Scotch-Brite pad. So the measurements showed only around 0.04 mm of misalignment. So I progressed to investigate the chuck. As I was cleaning it once again, I realized the screws and the back of the chuck were identified with punch marks. There is a set of 2, 3 and 4 marks matching each of the screws to a hole. There is also 2 punch marks identifying the correct alignment of the chuck and the back plate. I missed all those things when I was disassembling the chuck for the first time due to the amount of rust and grime. After reassembling everything, I indicated the chuck body itself again. The result isn't great, but there is a visible improvement. The run out went from about 1400s to around 900s. Measuring the silver steel rod near the chuck now indicates around 1600 and in the unsupported end around 1.56 millimeters. This isn't perfect, but it's a bit better. In order to make it better, I believe the next step would be grinding the chuck jaws. A few days after all this effort, I took the silver steel rod to work and indicated in a granite plate, and the bar is bent around 500s. So it isn't perfect and may account for some of the run out on the unsupported end. Now it's time to stop fiddling with the lathe and get on with the first cut. To test the lathe, I got a few pieces of aluminum round bar. This will allow me to start with something a bit more forgiving. The colleague who gave me the lathe also gave me a few already shaped high-speed steel tools and some blanks. I don't think the tool I'm using has the right rake for aluminum, but this is all I have. And this is my first ever operation in a lathe. I tried to go slowly not to break anything. For those paying attention, you realize that the tool was mounted wrong and it's configured to cut towards the tailstock and not towards the headstock. Thanks Adrian for pointing this out. I decided to test the tailstock chuck I got, but first I had to align the tailstock, which was still all over the place from being disassembled. In order to align the tailstock properly, I decided to cut a point into the aluminum bar and use as reference. This is my last attempt to use the cross slide to cut an angle. You can see here the entire chuck is being lifted by the tool. I think I need to tighten the grip on the spindle bearings and see if I can improve the rigidity. I decided to use a file to improve the surface finish of my cut, since it was very bad. Now I can properly align the tailstock using the live center as reference. Just as a point, the lathe is still not bolted to the bench properly. In order to test the concentricity, I decided to use a spot drill. Had to tighten up the tailstock so it doesn't slide back while drilling. The hole came out pretty centered, but I had to make several more adjustments later. If you're still here at this point, thanks again for watching and see you next time.